So we're going to be looking at the study guide for the first pre-algebra quiz on solving equations. Um, a lot of these problems are going to have very similar themes to them, but each one's going to have like a slight twist here or there, having to take care of a negative or doing a little extra step here to make it easier, that sort of thing. But there's going to be a common theme going throughout all of these, which is get the x by itself. So you usually will have two x's on either side of the equation, so one to the left and one to the right. You want to get those on the same side first, and then move everything else away from the x. Remember, your goal is to get the x by itself when you're solving the equation, or isolate the variable is the proper lingo there. So let's dive right into the first one here. So we have negative 2x minus 10 equals negative 25 minus 7x. Well, the first thing I usually do is I draw a line down the middle, just because that gives you two clear, distinct sides. So if I say move something to this side or move something to that side, you know what I'm talking about. And so again, the first step is to get your x's by themselves. We have a negative 2x and we have a negative 7x. So my rule of thumb is you move the smaller x. You don't have to, but that's my rule of thumb. So between negative 2 and negative 7 is smaller, because remember negatives are reversed. So I'm going to move the negative 7x. Now when we say move something, if we want to move it across this line here, we have to do the opposite of what's being done to it. So if this is a minus 7x or if this is a negative 7x, in order to move it, I have to do a positive or add a 7x. So the opposite is either the opposite operation or the opposite sign, or whatever you want to think about, whatever is easier for you to think about. Because what happens, our goal is that this will cancel out, which is good. We want it to go away. We don't want the x over there. We want it on the other side. And then this, negative 7x minus 2, would give me 5x. And then I just bring everything else down. And this is the important step here. You have to bring everything else down. Don't skip this step. Don't try to do it shortcut until you've gotten a hang of it, because when people try to shortcut and don't write their steps down, their format gets all messy and they make mistakes easier. So line by line, write everything you don't use down. Makes it a little bit easier to work with. So now my x is alone on one side. Well, alone in that there's only one x now, 5x. So now I want to get my x by itself. So I have to move that 5 and that minus 10. Okay, that's what I mean by itself. The x is now on the left side. I want to move the 5 and the minus 10 away from the x. I want to get the x alone. So what do I do? Well, again, I do the opposite of what's being done to get rid of the numbers. So if I see a minus 10, I'm going to add it, because that will get rid of the minus 10. And then whatever I do on one side, I have to repeat on the other. That's the golden rule for equations, is you can do anything you want, but whatever you do on one side, you have to repeat on the other. Now this goes away, and I'm left with 5x. Now the reason I moved the minus 10 first, by the way, is because you always want to get rid of your minus and subtractions and your additions and stuff first. You want to get rid of anything that's being subtracted or added first, and then get rid of anything that's being multiplied or divided, because when you multiply or divide to get rid of something, you have to do it to the entire side, and the less side you have to work with, the less you have to do. So get rid of all the addition and subtraction first. That way when it does come time to divide or multiply, you have less to do. Negative 25 plus 10 is negative 15. And then now this is 5 times x. That's what 5x means, 5 times x. So in order to do that, I'm going to divide by 5, because dividing gets rid of timesing, or multiplying, I should say. Now, once again, the reason I did this second rather than up here is because if I divided by 5 here, I have to divide this by 5 and I have to divide that by 5. So I save myself an extra division by getting rid of the 10 first and then dividing at the end. Not something you have to do, but something that makes it a lot easier. And then a negative divided by a positive is a negative, so this would be a negative 3 as our answer. And again, if you want to check that, plug a negative 3 in for x up here and there, and then you should get the same answer on both sides. Now, a lot of these are going to be worked the exact same way, just different numbers. So let's try this one here. The first step, get your x's alone. So negative 6x, positive 7x. Negative 6 is less than negative 7, so I'm going to move that first. So I'm going to add 6x here. I'm going to add 6x there. This goes away. I'm left with 7 equals, over here I have 13x plus 20. Now my x is on one side so far, so that's good. So I want to get rid of the 13 and the 20. Again, I'm not going to divide by 13 yet, because I want to save that for the end. I want to get rid of this plus 20 first. So I'm going to subtract the 20, because that gets rid of plus 20. And then whatever I do on one side, I have to repeat on the other. That way the equation stays balanced. This goes away. I'm left with 13x. And here I have negative 13. It's an equal sign there. Let me make it a little bit better. And then now 13 times x, how do you get rid of times? Well, you divide. Remember, when a number and a variable are right next to each other, whoops, just normal 13, not negative 13. When a number and a variable are right next to each other, that means multiply. So you get rid of that by dividing. And then a number divided by itself is 1. A negative divided by a positive is a negative. So this is a negative 1. That's all there is to it. Again, very similar to the first one, just different numbers. All right, next one here. Again, focus on your x's first, a negative 3x and a positive 6x. Well, I want to get rid of the negative 3x first because it's smaller. Again, just works better that way. So I'm going to add 3x. That way you kind of avoid negatives as much as you can. You can't always avoid negatives, but if you can, it helps. This goes away. I have negative 3 left. Again, writing down every step you do. That way your form stays good and your setup stays nice and clean. Now, I don't want to move the 9 yet because it's being multiplied. I want to get rid of the 60 first. Now, some people will freeze here and say, okay, what do I do with the 60? Because there's no symbol in front of it. It doesn't tell me whether it's a positive or a negative. If there's not a minus sign in front of the number, you assume it's positive. So, for instance, this 6 is positive. This 60 is positive. This 3 is negative because there's a minus sign in front of it. And so is this 3. There's a negative or a minus sign in front of that. So if there's no symbol in front of the number, not behind, I don't care about what's behind the number. If there's no symbol in front of the number, then you assume it's positive. So I'm going to subtract 60 from both sides because it's a positive 60, even though it doesn't tell me a plus. I know that it's going to be positive because there's no symbol in front of it. So this goes away. This is negative 63 because remember you have two negatives. So negative 3 minus 60 is going to make a bigger negative, and I should probably make that correct because I messed up on that. Let's try that again. 63. There we go. And then here's a positive 9. Again, sorry for the big handwriting. I'm using my mouse here rather than my normal pens, so my handwriting is going to be a little bit off, more so than it already is. And then now it's time for the division, right? Because it's 9 times x, so to get rid of times being like something, we divide. So divide by 9. Divide by 9. Once again, a negative divided positive is a negative, so it's going to be negative 7 equals x. Right. Again, very similar, slightly different numbers. This one, same way. Remember, this is a 1x, by the way. There's an invisible 1 in front of this x. You just don't write the 1 there, so you don't really see it, but it is still there. Now, just to show you that it works the same way on both sides, I'm going to actually do the reverse of what I did last time. I'm going to move the bigger x rather than the smaller x first, just to show you that it can work either way. So I'm going to move the 3x here by subtracting it because it is a positive 3x. Minus 3x here. I get 3 is equal to negative 2x minus 9. Now again, my goal is to get the x by itself, so I move the subtraction first. So plus 9, plus 9. Remember, this 2 is multiplied. This 2 is not subtracted to the x. This negative 2 is being multiplied to the x. Some people want to add this 2 to get rid of it, but again, you have to look at the operation. The operation is being multiplied to the x, not added. So this is a division to get rid of that. So I'm going to do that last. So I'm going to get rid of the 9 first. This is going to be 12 equals negative 2 times x. So now I get rid of that by dividing by negative 2. Oops. And then I get negative 6 equals x. Again, similar problem, same result, just moving the bigger x first just to show you that it works either way. Last two are solved very similar to the first few. I'll do this the normal way this time by moving the smaller variable. So negative 2 is less than negative 4, or sorry, positive 4. So I'm going to add the 2x to get rid of it because it is a negative 2x. Now the reason I'm adding this time and not dividing is because I want to move the entire 2x. So up here, the reason I divided is because I want to keep the x there. I didn't want to move the x back over here. I just moved it away from there up top. I moved it from this side to this side. So I didn't want to move the x back over there. I just wanted to move the -2. So division and multiplication, especially division, are kind of like precise movements. They allow you to move one specific part of a specific piece of the equation. So if I want to move just the -2, I'm going to divide by it because I want to move just that number and leave the x there. I want the x to stay where it's at. I just want to move the -2. Whereas over here, I want to move the x along with it. I want to move this entire chunk, this entire piece, this entire -2x, the -2 and the x all together. I want to move that over here. So I'm going to add to move the entire chunk there. So that confuses people sometimes. That's the best way I can explain it, is that division allows you to move just the specific part you want, whereas addition and subtraction allow you to move the entire chunk to where you want. So I want to move this entire chunk over there, so I'm going to move that by adding it because I want to move the x along with it. So if you want to move the variable along with the number, you're going to add or subtract. If you just want to move the number and keep the variable where it's at, you're going to multiply or divide. So this will cancel, and I'm left with a 2 equals 74 plus 6x. Now, don't want to move the 6 just yet. I want to get rid of that 74 first. There's nothing in front of the 74. There's no symbol, so I assume it's positive. So get rid of that by subtracting. Whoops. So I'm going to minus 74 and minus 74. This goes away. I'm left with 6x equals negative 72. And then this time I want to keep the variable where it's at. I don't want to move the x along with the 6, so I'm going to go ahead and use division in this case. So divide by 6, divide by 6, and I get negative 12 is equal to x. So again, division and to some extent multiplication are precise movements. They move one piece of the part, whereas addition and subtraction move the entire chunk itself. So if you want to move the variable, add or subtract. If you just want to move the number, multiply or divide. And the last one for this one here. -2 is smaller than positive 4, so I'm going to go ahead and add this 2x to both sides. Again, just like before, I want to move the entire chunk, so I'm going to add this time. Not going to divide because I want to move the x along with it. So that goes away. Negative 4 is equal to 6x minus 12. Now, again, I'm going to move the 12. Now, there is something in front of this 12. There's a minus sign. So I'm going to do add 12 because I know it's negative because there's a minus sign in front of it. They have to tell you if it's negative. They don't have to tell you if it's positive. If it's positive, there just won't be a symbol sometimes. If it's negative, there will be. Negative 12 plus negative 4. Now remember, this is a positive and a negative, so it's kind of like 12 minus 4, which gives you 8, is equal to 6x. Then, to get rid of just the 6 and keep the x, we're going to divide, because I want a precise movement here. Now, 8 divided by 6, you can make it into a decimal. I would actually prefer you just leave it as a fraction, but it depends on your teacher. So I would leave it as 8/6 and then reduce it. Obviously, you don't want to leave your fractions unreduced. So divide both of them by 2 is what I would do. And you get 4/3 is x. So for me, it's okay if you want to leave it as a fraction. Just make sure that you divide and simplify if you can to get down to a fully reduced fraction, not just one. Not just one unreduced one. I want one reduced fraction as the goal. If you want to change this to a mixed number, again, for me, obviously that'd be okay, or a decimal also would be okay. It just depends on the teacher that you have. So. Now, the last part here on the back page is a little bit about, whoops, too far. A little bit about solving for equations where there's very few, if any, numbers at all. So remember, when you solve for something, whether it be x or a or b or h or whatever, solving simply means get this variable by itself. It means I want this variable equals to something, or I want something equals this variable. It doesn't really matter what side you work on. So when it says rewrite the following formulas by solving for h, it means I want to get h by itself, and everything else I want to move away to the other side where h is not. So for example, number 11 here, V equals L times H, or sorry, L times W times H. I want to get H by itself. How do I do that? Well, I have to move the L and the W. I have to move these two pieces over to the other side. That will get H by itself. That means that H is solved for, and then it'd be done. Well, you can do this in two steps because what's the W doing to the H? Well, it's multiplying to the H, right? W times H. So how do you get rid of multiplying? You divide. So you could divide this side by W, and of course divide this side by W. But while you're doing that, what's the L doing to the H? The L is also multiplying to the H as well. So how do I get rid of the L? Well, I would divide by L as well. So I can just tack that on along for the ride. I can divide by L here, and I can divide by L there. So instead of doing it in two steps, I can get this done in actually one step because the two things I have to move are both multiplying to the H. So multiplication and division, you can kind of move multiple things at once by just tacking it onto each other. So if I'm going to divide by W to get rid of the W, I might as well divide by the L while I'm at it to get rid of the L as well. Because what's happening is that the W will cancel with the division, and the L will cancel with the division. And so what I'm left with is just H. And then on this side, I'm left with whatever there is. So V divided by LW. I can't really combine anything there. I can't multiply anything together. I can't reduce anything. So this would just be my answer. So I'm not looking for a single number answer for most of these. I'm simply asking you to rearrange the stuff so that H is by itself and then everything else is over to the other side. 12 is the same way. You have to get H by itself, so you have to move the B and the 2. And this one we're going to do in two steps just to make sure it's clear. So let's start by getting rid of the 2. Usually I like to get rid of division first if I can, just to make things easier. So the H is divided by 2. How do I get rid of divided by 2? I multiply by 2. And then whatever I do on one side, I have to do the other. So I multiply by 2 here as well, to both sides. This will cancel, and I'm left with BH, or B times H. Over here, instead of doing A times 2, I'm just going to do 2A, just because that's usually how you write multiplication with variables, is you write the number in front and the variable in back and just squish them together. And then how do I move the B? Well, it's B times H, right? So you divide to get rid of the multiplication. And then same thing over here. You divide by B here. And you're left with H is equal to the 2A we had over the B we just divided by. And that is an H, not a B. And so that would be your final answer. Notice again, we don't have a single numerical answer. We have some big mess over here is equal to H, which is the goal. You want to get it so that H is by itself and then everything else is moved off to the other side. Okay. So this is really no different than the front two, or the front few, but it's just that you can reduce less. So in the front ones, you can reduce everything down to a single number, whereas in this case, you just simply want to rearrange it so that it looks different. You're not looking to solve for getting like H equals 5. You're simply looking to get H or whatever variable it's indicated by itself so that it's alone and then everything else is on the other side. And then there's your new formula. The way this is used is that, for example, if I said, using this one up here, this is the volume formula, so the volume of a box is equal to length times width times height. If I said a box is a volume of 500, it has a length of, I don't know, 20, and a width of 7, how high would the box need to be in order to keep this volume at 500? Well, I could just plug all these numbers into this equation over here and get H right away. Just plug in 500 for V, 20 for L, 7 for W, do the arithmetic, and I can get H. Whereas if I had this here, if I had the formula I started with, I would plug in, whoops, that's an H there. My bad. Ah. Let me see if I can't do that better. V equals L W H. There we go. If I want to use this formula instead, I have to plug in 500 for V, I plug in 20 for L, I plug in 7 for W, and then I have to resolve this for H every single time I change V, L, or W. Whereas in this case, if I have 20 of these problems, I can just rattle them off real quick by using this formula here because it's already solved for H. All I need to do is plug in the numbers and do the arithmetic rather than solve the equation over and over and over and over and over again. So that's what the goal is here, is to get the variable by itself and then don't worry about whatever mess is left behind. that about covers this video here. Again, solving equations, getting a single numerical answer like what we did on the front page, or just rewriting the formulas to get the variable that you want by itself, so that's a little bit easier to solve for different types of problems. Hope you enjoyed the video. Have a good day.